Good morning, my name is Rogelio Nazar and I'm going to present this talk entitled Automatic Induction of a Multilingual Taxonomy of Discourse Markers. This research is brought to you by my sponsor, the government of Chile, with a research grant called Fondesit Regular 1191481. To the taxpayer in Chile, thank you very much. So this is the overview of my presentation. I will offer an introduction, some related works. I will talk about the methodology, show some preliminary results, and offer finally some conclusions. What we're trying to do in this project is to obtain a categorization of discourse markers, that is, words such as however, therefore, by the way, in different languages by applying statistical analysis in parallel corpora. The objective is to build a lexical resource consisting in a multilingual taxonomy. Results are so far in English, Spanish, German, French, and Catalan, which are the languages in which I feel competent enough to work with. A method is proposed that first separates the discourse markers from the rest of the vocabulary unit, and then organize this in clusters as a bottom-up taxonomy. Experimental evaluation shows that the results are pretty good compared to what a human annotator can do. It even outperforms the human annotator in terms of recall. Related work. The topic of discourse markers has been in the spotlight of linguistic theory recently, but the subject is by no means new. Aristotle already had a pretty clear idea of what they are and what they do, but I would like to mention some of the early grammarians in the Spanish tradition, such as Antonio de Nebrija, Gregorio Garcés, or Andrés Bello, who already talked about them. And I would also like to mention, in the modern period, the work by Professor Teun van Dijk, who in 1973 in this book already presented the main functions of what he then called the connectives. Another important precedent in the history of the field is this book by Halliday and Hassan, Cohesion in English, who already presented a pretty developed taxonomy of what they call conjunctive relations. Finally, I would like to mention the work by Anscombe and Ducrot, the argumentation theory. In this book, they already describe the functions of discourse markers, as we can see in the example. A mule is better than a donkey, even a bad donkey. We can see the example is absurd because of the wrong use of the discourse marker even. In the late 80s and beginning of the 90s, a lot of people tried to identify the defining properties of discourse markers, but that is not an easy thing to do. They are not easily defined. The only thing that we can say is that they are particles that facilitate the interpretation of discourse by connecting different propositions in the text, but they also serve to facilitate interaction between participants. So we can say that they are also pragmatic particles with an interpersonal function. They have some morphological properties. They have no inflection, they do not admit modifiers, they cannot be negated or coordinated, but some of them do. There are also syntactic properties. They tend to be utterance initial, they are often parenthetical, not always, but they seem to be outside of the syntactic structure of the sentences, but they operate in different levels of discourse. Some semantic properties are that they have a procedural rather than a semantic content. They do not participate directly on the propositional contents, but they have remnants of the semantic content that they once had, but propositional content has been gradually bleak. The only thing that we can say probably is that they have a functional properties. For instance, they can have a co-orientation of arguments in the case of the additive connectives, or they can be they can operate in counter-oriented arguments, such as in the case of counter-argumentative connectives. There are many efforts to try to classify. Perhaps the most well-known is the one by Martín Sorraquino and Portolés. They offer different types of categories of discourse markers and also offer some examples of each of these categories. But there are also many other attempts to taxonomize discourse markers in different languages. There is even a very nice multilingual discourse marker database that you can access down there. There have also been some previous attempts in the automatic extraction and classification of discourse markers, in particular in the area of discourse parsing, but I am mostly interested in those people working with parallel corpus. For instance, these ones that are here are trying to mostly project information from one language to the other. I would also like to mention my previous work with one of my students. In this case, we obtained from parallel corpus different parenthetical discourse markers in Spanish, but that was a knowledge-intensive and also a computationally expensive method. Methodology. The overview of the methodology is that we are using parallel corpus first to identify discourse markers by using an information-based coefficient. We offer a classification of the discourse markers in a functional taxonomy using a clustering algorithm, and then we tag these different clusters by applying a meaningful category name. Once we have this core taxonomy, we then proceed to recursively populate it with new discourse markers obtained from corpora. For that, we use the Opus corpus, which is the greatest corpus available online. It has many different corpus in single TMX files. There are approximately 30 TMX files per language. They are aligned at translation units, which usually correspond to sentences. They have no lemmatization and part-of-speech tagging annotation, but that's okay because we don't need it in this method. An initial vocabulary is obtained from the corpus by sorting words or sequences of 2 or 3 words without punctuation marks. A subset of this vocabulary is obtained by keeping only those units that appear in at least 7 of the 30 corpora, and then this subset is further reduced by determining a measure of information to each candidate. The key idea here is that since discourse markers have a procedural rather than a semantic content, they cannot be used to predict the appearance of other words. For instance, if we have the word Paris, we can say that it has a tendency to co-occur with other semantically related words, such as France, but this does not happen with discourse markers. So we can use an information-based coefficient loosely inspired in the work of Claude Shannon to distinguish these two sets. This is an example with the word education. If you extract all the contexts of occurrence of the word education, you will see that it tends to co-occur with others such as training, higher community, and so on. The same happens with words such as technology. It tends to co-occur with others such as research, development, information, and so on. This does not happen, however, with discourse markers. If you look for something like after all, it will see that it does not tend to co-occur with other words. So you can use the shape of the co-occurrence frequency curve to predict the semantic or procedural nature of the lexical unit. Next step is to align the words using the parallel corpus. For that we use an association measure. Using this association measure we can tell, for example, that the word nonetheless in English is equivalent to néanmoins in French, and this will give us the similarity measure between words in the same language. For instance, nonetheless and nevertheless we now know that are equivalent because they share the same equivalence with the French word néanmoins among others. So we can use this equivalence as a similarity measure in order to apply graph-based clustering algorithm. The result of this is a set of clusters of words that have the same function, but these clusters do not have a name, so we have to tag them using some known taxonomy. For that we use the taxonomy by Martín Sorraquino and Portoles, and we do this by finding the matching between the examples that these authors give for each of their categories and the discourse markers found in the clusters. Finally, when we have this core taxonomy already built, what we do is to further populate it with new candidates obtained from corpora. It consists of basically 3 steps. The first is to find the language of the discourse markers, which is done simply by corpus frequency. The second is to decide if X is or is not a discourse marker. This is decided by looking at the parallel corpus. If it is aligned with other discourse markers that are already known in the taxonomy, then it is taken as a discourse marker. And if 2 is true, then we have to assign X to a category. This is done again looking at the most frequent category of the aligned discourse markers according to the parallel corpus. Some preliminary results. So far, the core taxonomy has thousands of discourse markers classified in different categories and subcategories and in 5 languages. Results are very good in English, Spanish, French, and Catalan. They are not so good in German. We don't know exactly why. This is a cluster of the category counter-argumentative connectives in the 5 languages analyzed so far. And in order to obtain a more precise evaluation, we ask a group of students, of 7 students, to participate in a task in which they have to accept or reject discourse markers from a list of more than 700 candidates. And we compare their performance with the one of the algorithm, which is called DisMark, by the way. They all had good performance in terms of precision, in the sense that when they say that something is a discourse marker, it usually is. But humans tend to be more conservative, and they tend to reject less grammaticalized candidates, such as in these circumstances or in broader terms. So we can say that the machine has better recall. All results are available in the website of the project, which is techlink.com/dismark. Techlink.com is the name of the research group in the university, and dismark is the name of the project. Here you will have all the database of the discourse markers obtained so far, and also a demo of the automatic classifier that I described earlier. Conclusions. The main achievement of the project is to have obtained a new method for the automatic induction of a taxonomy of discourse markers. Some points to remark are the following. The method is very simple, it's effective, it's computationally inexpensive, it does not involve external resource apart from the parallel corpus, it does not require human intervention, it is easy to replicate in different languages, and as it is already interesting for theoretical linguists working on the subject. It is also interesting for people working in natural language processing, in particular those working in discourse parsing, information extraction, and maybe other fields, and also for final users, I mean writers and translators who would like to have more vocabulary richness, for instance. Some lines of future work. Well, we have identified at least 4 lines of future work. The first one would be to continue evaluating and exploring different variations in the method, to continue populating the taxonomy with new, maybe less frequent items, and also to incorporate new language. I am particularly interested, for instance, in Arabic and Swahili, and I would love to find people who would like to help. Final line is to experiment with the discovery of polyfunctionality. Polyfunctionality is a fascinating topic. It's a property of discourse markers to have different categories depending on the context. And that would be all for now. These are the references. Of course, everything will be also available in the paper, in the proceedings, and you can send me email. I would be delighted to reply.